Let's take a look at an example of how migration affects a population in Hardy-Weinberg equilibrium. Say we have two populations of lizards that live on either side of a wide river, one that lives on the east bank and one that lives on the west bank. 75 lizards from the east bank migrate to the west bank. We'll focus on one affected gene, skin color, with the alleles big R and small r. A homozygous big R lizard is red, a heterozygous lizard is orange, and a homozygous small r lizard is yellow. Before migration occurs, both populations are in Hardy-Weinberg equilibrium, with the east bank having 325 lizards and the west bank having 200. We can easily find the genotype frequencies within the populations by dividing the individual genotype population by the total population, resulting in the genotype frequencies here on the right. To find the allele frequencies, we use the Hardy-Weinberg equilibrium equation, finding the square root of the small r genotype value for the allele small r, then subtracting that answer from 1 to find the allele frequency for big R. Now let's see what happens after migration occurs. We'll use this equation to find the genotype and allele frequencies of the west bank population after 75 lizards have migrated from the east bank. In this equation, n is equal to the proportion of migrants after immigration, which in this case is 0.1875. Small p equals the initial frequency on the west bank before migration, and big P is the frequency on the east bank. So our allele frequency for big R would be found like this. Multiply 1 minus 0.1875 by 0.20 and add 0.1875 multiplied by 0.717. This is equal to 0.297. To find the frequency for small r, we subtract our answer from 1, which equals 0.703. Using the same equation and pre-migration genotype frequency values to find the new genotype frequencies, we find that homozygous big R equals 0.13, heterozygous equals 0.335, and homozygous small r equals 0.535. So, to sum up the effects of migration, mathematically, genotype and allele frequencies of the two populations move closer together, which means that the gene pools of the different populations become more similar, and variation is added to the recipient population.